This is problem number 50, and it's very similar to the deductible problem from a couple videos ago, but instead of the lower limit of the deductible, we have an upper limit of a benefit limit, so it's a maximum amount we'll pay. So we're given this little expression here, 2 times y to the negative 3, which will dictate the probability of any particular amount of payment. So the key thing to understand for this problem and problems like it is that the amount of payment is going to come in two parts. The first part is the payment associated with a loss that is between our lower limit and our benefit limit. The probability of that loss is given here, and to find the amount of that loss, we're just going to multiply by y to find the expected payment, right? It's just expected value. But that's only part of the story. We could have a loss that's much greater than 10. So the probability of that is given with this integral. But the amount of payment for a loss of 10, 20, 30, 40, 50 is going to be limited by the benefit limit of 10. So two pieces of the integral that we need to solve. If you were to just take this part and forget about this part, you would probably get to the end of the problem and think you had it correct when you chose C, because there's an answer choice waiting for you. But in fact, you would have forgotten this important piece of the amount of loss, the amount we're going to pay if the loss exceeds the benefit limit. So with this in mind, it's really just a calculus problem. There's a cancellation we can do right here, right? This is 2 over y to the third, so we're going to have a cancellation here. So I'm going to rewrite my integral from 1 to 10. I'm going to pull my constant out front and just keep things nice and neat. Same thing, pull the constant out front, though there's no cancellation here. So I'll just have 20 times the value of the integral. Oops, I just accounted for that too. There we go. Okay, and now let's proceed. Let's just integrate. Y to the negative 2 is going to become negative y to the negative 1, evaluated from 1 to 10, and of course we will have to multiply by our constant, plus multiply by our constant. This will become y to the negative 2 over negative 2, evaluated from 10 to infinity. And from here, it's just personal preference. I'm going to go ahead and I'm going to solve this way. So this is really 2 times negative 1. This is a negative 2 out front. It's personal preference how you go about solving the integral, what's easiest on your mind. Y to the negative 1 is the same as 1 over 10 minus 1 over 1 would just be 1, plus 20 divided by negative 2 would be negative 10 times y to the negative 2, so that's really 1 over infinity squared minus 1 over 10 squared. And of course, infinity squared, well, what do we do with that? Infinity squared is just infinity, and if we take the number 1 and divide it up into an infinite number of parts, each of those parts will be infinitesimally small and meaningless for our final answer. So this should do it. 1 over 10 minus 1 times negative 2 is going to be positive 1.8 plus negative 10 times negative 1 over 100th, because it's 10 squared. So that's going to be 10 over 100, or plus 0.1. We're just adding on another tenth there. So the final answer is 1.9. You choose D. And again, really need to emphasize, the calculus isn't the hard part here. It is setting up the correct integrals to begin with, and being sure that you understand that your expected payment comes in two parts. or the amount we pay if the loss is underneath the benefit, plus the amount we pay if the loss amount is greater than the benefit limit.